All right, welcome to the Explainer. Listen, today we are not just solving math problems. Nope, we are cracking codes. These exponential and logarithmic equations, they can look pretty intimidating, I get it, but they're really just puzzles, just waiting for us to figure out the key. So let's get into it.
So check this out. At first glance, it just looks like a jumble of math symbols, right? A secret code, maybe. Well, it kind of is. But here's the cool part. By the time we're done here, you're going to know exactly how to decode this thing, and a whole bunch of others just like it.
Okay, so here's our game plan for today. First, we're going to get into the right mindset for cracking the code. Then, we'll gear up with our detective's toolkit, the essentials. After that, we dive into two different case files, one for exponential equations and another for those logarithmic mysteries. And we'll wrap it all up with a really interesting case that has a surprising little twist. So, every great investigation starts with getting your head in the game. To solve these equations, you really do have to think like a detective. It's all about gathering the clues, knowing which tool to use and when, and just having a solid, methodical approach to find the truth that's hiding in the numbers. And of course, every detective needs their toolkit. This is so important. These aren't just a bunch of boring rules to memorize. No way. Think of these as your indispensable gadgets, the fundamental clues you absolutely need to solve every single case we're going to look at.
All right, tool number one. This is the big one. It's basically our secret decoder ring. You see, exponential form and logarithmic form, they're just two sides of the very same coin. They're saying the exact same thing, just in a different language. And knowing how to flip between them, that's the secret to getting unstuck. I mean, think about it. b to the power of x equals y. All that really means is that x is the exponent you need to put on base b to get y. Same idea, just a different way of writing it.
Okay, now this next tool, this is the master key. It's called the one-to-one property, and honestly, it feels like a magic trick. It is such a great shortcut. If you've got an equation and you can get the bases to match on both sides of that equal sign, you can just drop them, ignore them, and solve what's left. It just cleans up the entire problem so nicely.
And look at this, a perfect example of that master key in action. You see log base 2 on the left and you see log base 2 on the right. Since they match, poof, they're gone. The one-to-one property lets us just drop the logs and focus on what's inside. So what looked super complicated a second ago is now just x squared minus 5 equals 4x. That's just a quadratic equation. We know how to handle that. See how powerful that is?
All right, our toolkit's packed, we're ready to go. Time to open our first case file. This one is all about exponential equations. Our mystery variable, x, is hiding way up there in the exponent. Our mission is to figure out how to bring it back down to earth. So, here's our first mystery. 4 to the power of x equals 64. So what's our first move? We've got to find a common base. And you might just know that 64 is 4 times 4 times 4, which is 4 cubed. Perfect. So let's rewrite it. 4 to the x equals 4 to the 3. And there it is. The bases match, so we can pull out our master key, the one-to-one property. If the bases are the same, the exponents have to be equal. So x equals 3. Boom. Case closed. One case down. Now for our next file, logarithmic mysteries. This time, our x isn't hiding up in an exponent. Nope, it's trapped inside the logarithmic itself. So the strategy is going to change just a little bit, but that detective mindset, that stays exactly the same. So let's take a look. The first thing you've got to do every single time is get that log part all by itself. So we'll just divide both sides by -3. That leaves us with log base 2 of x plus 1 equals 8. Now we're kind of stuck, right? This is where we pull out that decoder ring and flip it into exponential form. Remember how? The base, which is 2 to the power of the answer, which is 8, equals the stuff inside, x plus 1. So 2 to the 8th power is 256, and if 256 equals x plus 1, well, x has to be 255. And of course, every good detective double-checks their work. If you plug it back in, yep, it works out perfectly. Now for our final case. You know, sometimes a detective follows all the clues perfectly, does everything by the book, only to discover that the suspect just couldn't have done it. It was impossible. This is one of those cases. It's a mathematical red herring. I mean, so far, we've been finding a nice, clean solution for x every single time. But does that always happen? Is there always an answer to be found? What do you do when the evidence just points to an impossibility? So let's investigate this one right here. 3 raised to the power of x plus 2 equals -1. Now, on the surface, it looks pretty normal, right? Just another exponential equation. But there is something very, very strange about it. So why does this case just go cold? It all comes down to a fundamental truth. Think about it. Our base is 3. That's a positive number. Now, can you think of any power, any real number at all you could raise 3 to and get a negative number as the answer? You can't. It's impossible. 3 squared is 9. 3 to the negative 2 is 1/9. It's always, always going to be positive. It can get really close to 0, but it can never reach it, let alone cross over into negative territory. So an equation asking for a positive base to equal a negative number has no solution. The case is unsolvable.
So let's review our essential detective strategies. Think of this as your go-to checklist. First, always isolate your target. Get that exponential or log term all by itself. Second, be on the lookout for a common base, so you can use that beautiful one-to-one property. It's almost always your fastest path to the answer. Third, if you get stuck, don't panic. Just use your decoder ring and rewrite the equation in its other form. And finally, as we just saw, always check your work to make sure your solution is actually possible and not a dead end.
And there you have it. We've seen that these problems, they're not really about complicated calculations. They're about strategy. They're about applying the right tools and thinking like a detective. You now have the toolkit. You've got the strategies down. So the only question left is, what mystery will you solve next?
Like, subscribe, and comment what type of problem you want next.